Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fasti, Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today we are here for our live webinar titled How to Boost Your Biobanking Process, and we will discuss together the different freezing methods and how to improve your biobanking workflow. Before giving the floor to the speaker in the laboratory, I would like to focus your attention on this slide. You can see the basic functions of the Zoom platform through which we are broadcasting. The meeting controls are at the bottom of your screen. They hide if you don't use them, but they reappear if you move your mouse over them. Your microphone will be muted for the entire webinar, but this webinar is intended to be interactive, so we encourage you to ask questions, and you can submit questions anytime using the Q&A box. So you can see the icon in the down part of your window. Please write as many questions as you want, and we will reply to the questions at the end of the presentation. There will be a live Q&A part. Also, you can find the chat box icon to communicate with me in case of any technical problem. Now, a quick, let's look at the speaker today. The speaker today is Miriam Baroni, application specialist in Milestone since 2013. Miriam has a master's degree in biotechnology and a PhD in medical biotechnology. She has been working in Milestone for many years, mainly focusing on tissue processing and frozen section. Now I will take off my presentation, and so I can give the floor to Miriam for her presentation. So Miriam, now you have the floor.
Thank you, Michela, and good day, everyone. I'm Miriam, and I'm part of the Milestone application team. Today, I would like to speak about biobanks, especially for those biobanks in which it's really important to preserve the viability of cells. Let's start from the basis. Biobank is a biorepository that stores biological samples for future use in research, gene therapy, transplantation, and regenerative medicine. So it is an important support for the healthcare, especially to find novel disease markers, but also new strategies for therapies. What is the general workflow of a biobank? It starts from the sample collection that is then divided in aliquots, and then these samples are frozen at very low temperature. At this point, they are stored in a very big freezer that are well organized. It's important, the organization of these biobanks, because when a sample is necessary, it must be found in an easy and fast way. Moreover, biobanks must carefully document sample and donor information. Otherwise, the single sample is not helpful. Biobanks can be classified in 4 categories based on the sample type. That can be cell line, blood, specimen, and images. Imaging biobanks is quite new, and it's the storage of bioimages like magnetic resonance, tomography, PET, that allow to discover new marker disease that are not invasive. Moreover, biobanks can be also divided in 2 groups based on the aim. So we have population-based biobanks in which the aim is the study of complex and common diseases, while in these disease-oriented biobanks, or samples of a specific disease are stored, and they are used primarily to study cancer. Today, I want to focus on biobanks in which it's really important to preserve the viability of cells, like biobanks of stem cells, cell lines, and tissues. Here, the cryopreservation is fundamental because at low temperature, biological and chemical reactions are dramatically reduced. So, what is the cryopreservation? The cryopreservation is the use of very low temperature to preserve cells and tissues for a longer period of time. Basically, at low temperature, samples are maintained in a state of suspended animation, so they are blocked and still, while their structure is preserved, so that when they are brought back to living temperature, the cell can work again, can make their function, so they can come back to life. The cryopreservation steps start with the mixing of cells or tissue with the cryoprotective agent. We will see it later on. The freezing of the sample to a very low temperature and the storage. I remember that the storage must be well organized and documented. Then, when a sample is necessary, it must be warmed up, and this warming up must be very fast in order to allow the immediate removing of the cryoprotectant agent. This reagent, in fact, is toxic at living temperature for cells. The most critical steps in all these phases is the freezing of the sample, because it's when a cryo-injury can happen. So, what is a cryo-injury? It's a damage of the cell associated with the water-to-ice transition. We have two kinds of problems, of damages. The first is the osmotic problem caused by concentrated solute. As water freezes, the molecules and the electrolytes content in it became more concentrated in the water, not frozen water. And this higher concentration can create problems to the structure of the cell. The other problem is the ice crystal formation inside the cell. As you know, the solid state of water is bigger than liquid state. In fact, when water freezes, it organizes its molecules in a crystal that is bigger in volume respect to the liquid water. These two problems depend on the freezing rate. If the freezing rate is too rapid, water has no time to exit the cell, remain inside the cell, and create ice crystals. While if the freezing is too slow, we can have a solute injury. Now we can see which are the factors that affects the cryopreservation quality. The first two, cell type and sample type, are unmodifiable, while we can act on a cryoprotective agent and freezing methods. Let's see in details all these factors, starting from the cell type. As you know, each cell type has a different membrane features, and this drives the choice of the correct cryopreservant and the optimal cooling rate. Also, the type of the sample influences the freezing. In fact, dimension of the sample affects the heat and molecules transfer. It's easy to imagine that it's different to freeze a bulk system like tissue respect to a cell suspension. The cryoprotectant is the other factor affecting the cryopreservation quality. It's a fluid able to reduce the freezing injury, and we have two kinds of cryoprotectants. The first is the cell membrane permeating, in which we have DMSO that is the most famous. This kind of cryoprotectant allows the reduction of the electrolyte concentration in the cell. The second type is the non-membrane permeating that acts reducing the ice crystal size. Speaking about cryoprotectant, I would like to show this table in which we have a summary of many studies made to find the perfect cryoprotectant for each specific cell type. Many studies are necessary to fine-tune the cryopreservation procedure because each specific cell type requires different precautions in terms of cryoprotectant type, cryoprotectant concentration, but also freezing methods. And in fact, the last factor that influences the cryopreservation quality is the freezing method. We have 4 methods. The slow freezing and the vitrification are the most common and used. Then we have also the sub-zero not freezing storage that is good only for short-term storage, and the preservation in dry state that is not possible in mammalian cells because in these cells it's very difficult to introduce thiolose and amino acids. Let's see in more details the first 2 methods. The first method is the slow freezing. It allows the exit of intracellular water so that the ice crystals forms only outside the cell without damage its structure. To achieve this slow freezing, cells must be put in a system that controls the freezing rate, and a cryoprotectant that improves the membrane permeabilization is necessary. I think that you already know this method. Anyway, its main features are that it is easy to do, it requires low cryoprotectant concentration, and it has no risk of contamination because samples are frozen inside sterile vials. As you know, we have 2 main methods to achieve the slow freezing. Mr. Frosty, that is a small container that when put at -80 degrees, allow a freezing rate of about 1 degree per minute. So it's easy to use, it's cheap, but it doesn't allow a controlled rate of the freezing. Then we have the Cryomed freezer, that is a freezer in which the cooling down is based on the liquid nitrogen injections that is controlled. So it allows a customizable freezing profile. Because of the use of liquid nitrogen, this system is unsafe. In fact, liquid nitrogen is associated with the risk of burns and oxygen depletion, and is expensive. Vitrification is the other way to freeze a sample, preserving the viability of cells. It is the solidification of the aqueous part of cells in a non-crystalline glassy phase, thanks to the direct exposure to liquid nitrogen. Basically, in this case, the freezing is so fast that water has no time to organize its molecules and has no time to create ice crystals. So it remains small, like in the liquid phase. In vitrification, few microliters of sample are put on a solid surface or inside a small glass tube, and then directly immersed in liquid nitrogen. After this super fast cooling, samples are transferred in a sterile cryovials and then in the biobank freezer. Here we can see all the features of vitrification, but also its limits. For example, it is difficult to do because it requires good manipulation skills. It requires also high cryoprotectant concentration and it has a high potential of contamination. In fact, the samples are directly in contact with the liquid nitrogen. Moreover, it is unsafe because of the use of liquid nitrogen, and it strongly depends on the volume of the sample. So it's not perfectly good for big amount of cells or for tissues. To sum up, I would like to show you this table that compares these two freezing methods, slow freezing and vitrification. I highlighted just two important aspects. The first is that vitrification is not good for a big amount of samples, so it's not good for tissues. And the second one is that the slow freezing is more adaptable to the specific requirements of each cell type. In fact, we can modulate the slow freezing, we can't modify the vitrification method. So we have seen that the best way to freeze a sample, cryopreserving the viability of cells, is the slow freezing. However, the actual methods used have some limitation. For example, Mr. Frosty can't guarantee the perfect and constant freezing rate, and it allows only one freezing speed, that is about 1 degree per minute. On the other hand, controlled freezing devices are not safe because of the use of liquid nitrogen and can't allow to set up different freezing speeds in different freezing moments. Both systems don't document the freezing curve, the freezing profile of a specific sample. So, to overcome all these aspects, Milestone has developed a new freezing device that now I would like to present you. Flash Freeze is the Milestone solution to achieve the perfect slow freezing. It allows to do a fast freezing at -80 degrees, but also a constant and settable freezing rate. Now I change the camera zoom just to show you better this instrument. As you can see, it is small and compact. In the working area, we have a freezing container in which we suggest to put ethanol that is surely safer than liquid nitrogen and isopentane. It's possible to set up the working temperature at -80 degrees or to set up a freezing rate with a speed that is between 1 and 5 minutes for every degree. In this unit, it's possible to freeze sample in cryovials and in cryomolds. The flash freeze technology is the Stirling cooler motor that allows this controlled cooling down. This motor is inside the unit and is compact with low vibration and noise. The cooling action is made by the compression of helium inside the sealed chamber. So basically, it doesn't require any maintenance. As I told you, in flash freeze, it's possible to freeze both vials or cryomolds. In case of vials, okay, we have the freezing container with its cover, and here we have a tool that keeps down the vials inside the reagent here. Here we have one of the two racks present in the flash freeze unit. This is the random rack in which we can freeze one sample or up to many samples. So in this case, with the standard vials of 1 ml, it's possible to put up to 25 vials. Thanks to its space, it's possible also to freeze bigger vials, like these 4 ml vials, also tubes of up to 15 ml, so think about blood tubes, but also a bigger container like this vial of 50 ml. We have also this other rack that allow to freeze a sample already organized in plate. Okay? It's possible to insert a plate of 96 vials or 48 vials, so the one that is used in the lab. And it's possible to work in two ways, or have a complete plate that can be inserted in the freezing liquid and frozen directly at -80 degrees or following a freezing rate. Otherwise, it's possible to insert in the freezing container an empty plate, bring it at -80 degrees and add the sample as they are prepared for a snap freezing. When the plate is full of, at the end of the working at the end of the working day, it can be transferred to the biobank. Another interesting feature is the possibility to freeze a sample in cryomolds. We need to use a specific kit, and as you know, cryomolds are plastic mold in which it's possible to freeze a sample with a cryo-embedding compound in order to have a block that can be cut in a cryostat. Freezing sample in cryomolds, it's not easy. Because they must be put on the level of liquid nitrogen in order to have a very fast freezing on bottom of the cryomold without overspilling of the reagent inside the cryomold. To achieve this, Milestone created a kit in which we have this small container that can be inserted, that must be inserted in the bigger freezer container, and it must be filled with ethanol. So that when we use this particular cover, in which we can insert up to 3 cryomolds, when we close the freezing container, the cryomolds will be perfectly at the correct level of the liquid, freezing liquid, in order to have the better freezing of the cryomold without overspilling of the reagent inside the sample, so avoiding problem of contamination, cross-contamination, and the bubbles inside the block. So, flash freeze can be used in two different modalities, or setting up the working area at -80 degrees and insert the sample or directly at this low temperature for a fast freezing, or set up a constant and slow freezing rate. When a fast freezing is necessary, the reagent temperature is brought at -80 degrees and the sample directly immersed in it. This freezing requires a few minutes or a few seconds, because it depends on the sample type and volume. When frozen, the specimen can be transferred to the biobank and the device is available for the freezing of other samples. Today, I would like to focus our attention on the slow freezing because, as I explained before, it allows to better preserve the viability of samples. So in flash freeze, we have a gentle freezing. Gentle freezing is a controlled and constant cooling down of samples. It is controlled because it gives the possibility to decide the starting temperature, the ending temperature, and the freezing speed. And during the freezing rate, it creates a curve that documents the freezing process followed by the sample. It is constant thanks to the proportional integral derivative controller that modulates the energy of the cooling down in each single moment to follow the desired freezing profile. Let's now see in more details how to set up a gentle freezing. As I told you before, each cell type has a different time to allow unfrozen water to pass through cell membrane. Flash freeze gives the possibility to set up a freezing speed between 1 and 5 minutes per degree, but also the chance to decide two different speeds before and after minus 40 degrees. In this way, it is possible to test different freezing protocols and find the perfect one for a specific cell line or a tissue type. For example, if you set up the maximum speed in both steps, you reach minus 80 in about 2 hours. Instead, if the minimum speed is chosen, the freezing time to reach minus 80 requires about 9 hours. So now I want to show how it's easy and smooth to execute a gentle freezing. First thing, you need to start the procedure. And at this point, it is possible to set up to decide the starting temperature. It depends on the temperature of the sample. So if your sample are on ice, it's better to set up a starting temperature around 0 degrees. If the samples are at room temperature, it is better to set up a temperature between 20 and 25 degrees. At this point, you press start and the system starts the cooling down or the heating up of the working area, depending on its actual temperature. When it reaches the correct temperature, it gives a sound and keeps this temperature until we start the real process. These steps normally requires few minutes. When the starting temperature is ready, it is possible to insert the ID code of the sample to link it to the freezing process. This is an important point for the documentation. Now we can insert samples inside the flash freeze working area and start the freezing process simply pressing the icon, the starting icon. The system will follow the preset curve, and you can see on the screen a graph with the gray curve that is the preset curve decided during the setting up of the gentle freezing. At the end of the freezing program, a sound alerts the user while the system keeps the temperature until the operator can move the sample to the biobank freezer. As you can see in this example, the gray preset curve has been followed, while after reaching the ending temperature, this has been maintained for about 3 hours. All the freezing programs are saved for documentation. In a dedicated section on the flash freeze screen, it is possible to see the freezing curve and all the process details. Between them, we have the ID code of the sample or the samples. In this way, it is possible to see which freezing profile has been used, has been executed for this particular sample. It is also possible to view the curve and all the details on a personal computer using the LogViewer free software. Now, to conclude, I would like to sum up what I have discussed today. Flash freeze. In flash freeze, we have the gentle freezing that is without liquid nitrogen, so safe for the operator. It follows precisely the desired freezing rate. It is flexible because it allows different freezing speeds and can freeze a sample in vials and also in cryomolds. And it documents all the freezing profiles of each sample. So it summarizes all the important features to achieve a perfect slow freezing. I hope my presentation has been clear and useful for you. Now, just 2 seconds to change the camera zoom, and I am available for all your questions.
Thank you, Miriam, for your nice presentation. I am receiving a lot of questions, so now I will start with a few ones for you. Okay, first question for you, Miriam. How many case IDs can be linked to the freezing curve?
Okay, thank you, Michela. Basically, is an infinite number. You can add how many samples you have. The limit is done by the space in the freezing container. Maybe I move the camera. Okay, so the number of samples that you can insert here, you can insert the same codes in the software.
Okay, let's move to another question. How can I control the level of the reagent?
Yes, that's an important point. In both random rec, maybe I zoom in so it's better for you to see. Okay, so as I told you before, we have 2 recs for plate and the random rec. In both of them, we have this engraving on the lateral side, here and also here, so that when the rec is inside the freezing container, you can see exactly when where the level must be arrived. And if during the freezing the reagent goes down, you can add some other reagent in order to restore the perfect level. And immediately you can see if it is correct or not. Moreover, in the working area, we have also this container in which we can put some liquid, some ethanol, in order to have it at -80 degrees, so that when we add this liquid, we don't change the general temperature of the freezing container. Of course, sorry, Michela, in case of cryomold, the level is done by this set level container. So this must be maintained full. Okay, also using this spare liquid in the rare container.
Okay, let's move on to another question. Which type of cryomold can be used? And can I use the round cryomold in the flash freeze device?
Yes, surely. Basically, all the Sakura cryomolds can be used in our system because, as you can see here, for example, I put one biopsy cryomold, so very small. Also, the intermediate cryomold can be used, and also the standard one, the bigger one. But also the 2 round models present in the Sakura type can be inserted in this special cover and used for the freezing. Okay, so it's very easy to use all of them. Speaking about cryomolds, give me just a few minutes because I want to show you that in the cryomold kit, we have these 2 tools that I already explained you. So the container to set the perfect level and the cover to immerse correctly the 3 cryomolds. But also we have this tool that can be helpful to prepare sample at room temperature before the freezing, and also this other tool that allow you to store some sample after the freezing. So imagine that these cryovials are frozen, at this point, we can keep it in this container. I show you better. Just to preserve them for a short time at -80 in the flash freeze. Then these cryomolds, maybe up to 6 cryomolds, can be moved to the biobank freezer. This tool allows to keep the sample at -80 for a few minutes because this metal part keeps the temperature, while it has this plastic part that avoid to burn your hands. Of course, you need to use this tool with the gloves, but that's normal. But anyway, the plastic insulates better the cold for your hands.
Thank you, Miriam. Speaking of cryomolds, we have another related question. Are the cryomolds disposable or reusable?
No, normally they are disposable. Because the normal use of the cryomold is to insert the sample, then the cryoembedding compound, so that at the end of the freezing you have a block and you can use it in the cryostat. But when you pop up the block, you basically damage the cryomold, and normally they are not used. It's better to change it also to avoid cross-contamination between samples.
Perfect, thank you. Let's continue with other questions. We are receiving actually a lot of questions, so let's see if we have time for a few other ones. Do you have any comparison which qualifies the flash freeze?
We have an interesting interview to a laboratory in France in which they speak about their work with the flash freeze for freezing sample and compare it to their conventional method. So I think that is an interesting article to see if you need. Also, for all the interesting article about flash freeze and also other our units, you can see our website, our Milestone website.
Yes, thank you, Miriam. Correct. All the publications and case studies actually can be found openly on our website. Let's continue with other question. Is it compatible with any rack of cryotubes with the same size, or does it require specific tubes and racks?
For the freezing in cryotubes, in cryovials, it's possible to freeze all the vials that you want. As you can see, with this rack, you can put the size of the tube that you want and the type of the tube that you want. The important thing is that it's well closed because it is immersed in ethanol. In case of plate, it is possible to use plate for 96 vials, for 48 vials, so the one that you prefer. The important thing is that the plate is a standard plate, so with this dimension, about 10 centimeter per 8 centimeter. In our manual, you can find the perfect size. I don't remember now, but they are the standard plate normally used in all the labs.
Perfect, let's continue. Can you create different profiles for different laboratories, for example, so each laboratory can use its own protocol?
Yes, of course. This is one of the main features of flash freeze. Sorry, I want to change again the zoom just to show you better the screen. Okay, I'm not really good in technology, as you can see. Sorry. Okay, so when we enter in the settings page and we open the setting for the gentle freezing, as you can see, we can set up the speed that we prefer to freeze the sample. So we can decide to set up a specific profile for one lab and another profile for another lab, or two different profiles in the same lab for a different sample. So for example, if you have a stem cell, is just an hypothesis, maybe it's better to freeze them in a very slow way. So you can set up a minimum speed in the first range and the minimum speed also in the second range. In this way, the freezing is really slow, and maybe it preserves better the cell viability. If in another lab they want to freeze a cell line that is maybe stronger, you can set up a freeze that is a little bit faster. For example, 2 minutes every degree for the entire curve, or set up a faster speed in the first range and a slower speed in the second range. Because as you know, at very cold temperature, all the transfer, all the movement, all the action are dramatically reduced, are slower. So maybe it's better to freeze at a lower slower rate.
Okay. Let's do another question, Miriam. Can you leave the freezer on overnight and transfer samples to biobank next morning?
Yes, surely. When you set up the freezing profile, you can start the freezing when you want, so also at the end of the working day. So the system will follow the set profile, and the next morning you will find a sample correctly frozen and at the ending temperature that normally is -80 degrees. The system keeps the ending temperature for an unlimited time. So you can also run an over weekend program. Also, if it is only 2 hours program, then the system will keep the -80 temperature until Monday morning.
Thanks. I guess we can reply to one final question and keep a few other questions for the written form. We will reply in via email because time is actually running out. So last question for you, Miriam. Can this machine be used for rapid extempore diagnostic for routine histological lab? I mean, fresh frozen sections.
In some lab, they freeze a sample in a cryo mold for frozen section. And this unit can be used. So you need to set up the kit for cryo mold, set up the -80 temperature and freeze sample in a very fast way, having then a block that must be then attached to the chuck of the cryostat, and then it's able to be cut. What we normally suggest, the best choice in our opinion is to choose a Presto Chill for frozen section. That is a dedicated unit for include and freeze a sample for frozen section. It's a unit very similar to flash freeze, so it's very small and compact, but in the working area we have different tools. So we have some 6 metal molds that allow the perfect freezing in a face down system of a specific sample for frozen section. In this case, the working temperature is in that case the working temperature is -40, and this temperature and the direct contact of the sample with the cold metal allows a so fast freezing that the water has no time to create ice crystals, giving a very good and high quality frozen section with the best morphology preserved.
thank you, Miriam, also for the explanation of frozen section. Maybe this topic will require another dedicated webinar. Okay. So unfortunately, time is running out, so we have very few questions left, and we will reply via email in the next days. So let me show you one final slide with our contacts. So if you need any type of information from us, if you want to request a customized virtual demo based on your specific laboratory needs, you can write us and we will arrange a customized virtual demo for you. Also, keep an eye on our educational webinars scheduled for the next month. The registrations will open soon. And you can also stay up to date with Milestone news and events following us on our social network. Thank you very much for your participation today. You will receive an email tomorrow with the recording of this webinar, and we wish to see you all next time. Thank you and goodbye.
Thank you very much. Bye-bye.
Bye.